Okay, so no demos can fail now. Hi, I'm Michelle. I am a CIO at Soliance. I run a microservices practice at Soliance. Our team does a lot of migrations for customers to various orchestration platforms with Docker. And actually, we did a Docker data center migration last year, which was interesting. Now you would know that as Docker Enterprise Edition. So lots of fun stuff. Today, right now, I'm going to focus on the .NET experience for Windows developers. So I'm going to carry forward here. Why Docker? Of course, you've heard a lot about this already, but we like it that it enables a microservices architecture strategy. The business people like that because they hope for faster releases, because we have this full stack encapsulation, isolation between parts of the business, the domain, and we get to hopefully ask for new features across the board, and magically it will deploy without regression if we have done our job right. We have polyglot technology capabilities. I can hire people from different places that have expertise in different platforms. We can still mix and match those within the containers or separate containers and deploy them in a holistic orchestration platform. And of course, I have some improvement with my developer workflows because I have things like, just Docker is easy to work with, first of all. Second of all, I can encapsulate all my requirements for the developers as well and do a compose up and have everybody up and running quickly, which we do a lot of these days, and I find that to be awesome. Of course, microservices does come with some complexity. So we do need a DevOps culture around it. And because we are doing instrumentation and automation and looking at failure and recovery early on, we actually have a hope of better resiliency in the system, arguably something we should have been doing all along. And now we get to do because we are forced to, and we like that, I think. So .NET developers also have specific benefits with Docker beyond what I just stated, which kind of goes across the board, right, around microservices architectures. With .NET, we have, maybe some of you have legacy applications. What is that? Anything before .NET Core, right? So .NET 4.6, .NET 4.5, maybe a couple of WCF services sitting out in .NET FX3, and they still work. And the business doesn't have a lot of motivation to rewrite the whole application, so of course we need a way to incorporate that in our future plans around our orchestration platforms and the new things that we develop. And we want the isolation of containers and all the benefits that come with that. And the good thing is that with Windows containers, we actually have an opportunity to do that with limited changes. We can encapsulate the dependencies of these nasty old applications, build them into the Docker file so that the container has everything that it needs, separate from the rest of the ecosystem of our solution, and later decide to refactor when we have time to really think it through. So that's a good thing. In the meantime, we can build new applications with .NET Core and AspNetCore, and those can be targeted for Linux or Windows containers. So we have some options here, depending on our orchestration plans around the whole solution, around the enterprise. And maybe there's going to be a mix of that sometime. And we also get our familiar developer experience, which is really important, especially for those that are working with Visual Studio day to day. We still want to be able to do that when we move into this new world, right? So this is something that is very important. Now, let's come back for a moment to the idea of the legacy code, because this is important. We need the ability to encapsulate those dependencies for our applications into the container so that it's seamless, so that it can be actually migrated to containers so that we can actually have that works on my machine and everywhere else experience. And so I just wanted to go through a couple of examples of things you can do with your Docker file that are sort of more around the .NET developers' focus. Here's an example Docker file, which is actually the IIS Docker file. And what it illustrates is, a Windows Server Core base image. And it shows you that you can, for example, add Windows features. Great. That means, in this case, IIS, and in your case, possibly other things that your app needs. We've got the ability to copy and run existing executables in the container and make that the entry point. So in this case, it's Service Monitor to keep IIS alive. You also may have the need for .NET FX3 applications. I did a lot of WCF in my day. There's probably a few migrations of that nature in my future, maybe yours. But the idea here is, it also illustrates that we can add whatever required packages we need, whether it be .NET FX3, whether it be other items. And in addition, customize IIS requirements. So that's something that, some folks need to do quite a bit of when they deploy applications today. Your application pools, your settings that are, the configuration settings of IIS in general, maybe some of the websites, maybe you have more than one website. So these are things you have control over also with the Docker file. And then lastly, just to point out that whatever it is your .NET Framework platform is, you can incorporate that into your Docker file. And this particular Docker file inherits from the Microsoft IIS base image, and this produces my Microsoft ASP.NET base image, which is exactly what I'm going to use with the migration towards the end in my final demo, or in my almost final demo. So, the moral of the story is you can contain whatever it is you need. You can set up the dependencies of your application with your Docker file for Windows traditional applications. And Microsoft does provide a lot of those base images I just showed you as part of their Docker store. And so we have base images that are focused purely on the actual operating system. So we've got NanoServer for the lighter weight headless deployment within a container. And then we've got Windows Server Core for those full-fledged beefy legacy applications that we can't quite lose yet. And then Microsoft IIS, which gives you the baseline for an IIS setup. We also have various images that support your .NET environment. So those would inherit from the appropriate base image, right? Or layer on top. And that would be for .NET Core, for AspNetCore. We even have a build image, and I'm going to use that in one of my demos, so you'll see what that's for. And then in addition, we've got .NET Framework images that layer on top of the Windows Server Core and IIS, typically. There are images also available for SQL. Not that I'm deploying that as part of production, of course, but it is very useful in development potentially, because sometimes you just need developers to be able to onboard, run, have their own copy of the database, work offline for goodness sakes, how about I'm on a plane, and it works. And we do quite a lot of that actually in other environments that we work in, even with Event Store, Postgres, Kafka, the ability to compose up and have all the things work for this new developer we just onboarded. So things like this enable that, and it's nice that we have a developer version of SQL Server, one for Linux and also for Windows, so that we can do that kind of thing as well. So let's talk about Docker for Windows. This is the easiest way for you to onboard with Docker if you're a .NET developer today. So you would install Docker for Windows. It's a developer tool. It goes on your Windows machine, and it is a native application that enables you to build Linux or build to Linux or Windows containers and run them and test. So you can use any command line or command shell that you like. PowerShell happens to also work as well. So if you're familiar with PowerShell, has nothing to do with the Docker CLI. It just happens to be another shell that you could stay in while you're doing other things too. The CLI commands are the same between, Bash and PowerShell. Some subtle differences with maybe some variable conventions with a $, for example, $sign. Other than that, exactly the same commands. And so it's native to your experience with Docker as well. And then, when you're running against Linux containers, so when you're testing and deploying to Linux containers, right now we actually have a VM that supports that, but as you probably heard earlier today, that there are some changes forthcoming that will make this a more native experience so that you don't need the VM. So currently it's a Hyper-V VM that we're running against when we're doing Linux containers. And then you can verify the mode you're in. So if you type Docker version, you can see that you're currently using the server, which is the Linux server. And if you go to the tray, you can see that you can switch to Windows containers. So either of those are ways to verify where you're at. I don't know if you want to take bets on whether or not I forget to switch as I go back with the demos, but you can feel free to do that. Just, stay handy in case you need to tell me I forgot. Once you switch over to Windows containers, you're going to be able to do another Docker version and see that you're using the Windows OS image. So that would work, and then you could switch back to Linux containers. So this is stuff you'll just see me do. Thought I'd bring it up front here. And lastly, so I have Docker for Windows installed. What does that do? It gives me the Docker machine available, so I can type my CLI commands and I can do all the things I would normally do at the command line, whether I'm on a Linux box, my Mac, or now Windows, even in PowerShell. So it's exactly the same experience. But Visual Studio also provides us with tools that integrate with Visual Studio specifically on top of that. So it's not really part of Docker for Windows, but it leverages Docker for Windows to provide that experience, okay? So that's what we're going to be talking about. Now, developer considerations that I'm going to just touch on as I go through will be things like target environments and the base images that we use, the debugging experience so you can see that that works, access to logs, just understanding a little bit about that because I'm in Visual Studio, service dependencies, networking, so we'll do multi-container compose up, and then environment variables, some tricks, things to know, and CI/CD at the end. So keep going. Let's start by doing just a project new, right? So when you create a new project in Visual Studio, the idea is you can enable it for Docker right away. So I'm going to go through the process of creating a new AspNetCore app or solution or project. And then that project, I will first target with Linux containers, and then I'm going to switch over to Windows and run the same. Okay? So that's, I guess, the first thing that we'll focus on. Okay. So let's head over to Visual Studio. I'm going to just put these on so I can see better. And I'm going to open a new project. And I'm going to select AspNetCore. And let's go ahead and put this in a directory that I'm using. So we'll go to DockerCon, and we'll call this Demo1. And it will ask me what kind of app. I'll just select Web API, keep the default, and you'll notice that it enables Docker support out of the box. I can turn that off, but I won't. It requires Docker for Windows under the hood. So what this will do is generate for me a new project in the traditional way. I'm going to have a default controller with some basic capabilities, and then I'm going to have some Docker assets added to the solution as well that I should be able to run with quickly. So we'll take a look at that output. And here's my solution. Open up the controllers. And open this guy. Make the little room here. Okay, so here's my default controller out of the box. We've got the get values, and then maybe I'll put a breakpoint on one of these just to show that when we get to it, we'll be able to hit breakpoints as well. It does have a Docker file that came with this new project, and it's actually based on the Microsoft AspNetCore 1.1. So the template is AspNetCore 1.1. The base image is compatible with that. It's a Linux base image, and so this will be targeting Linux containers. Okay. You'll also see the entry point is the demo 1 DLL that gets produced out of this. And if we kind of go over here, you're probably familiar that Kestrel will be the web server that is used out of the box here, right? So it's going to layer my container with Kestrel as well. And you'll also notice I have this Docker Compose folder. So this is a Docker project. And actually, just to show you something, here it says to start the application with Docker. This would normally be my F5 experience. If I right-click here and set this as a startup project, this flips over to IIS Express. So the idea is I can still go back and forth, not that I have any reason to because this is so easy to work with, but the point is, where you want to be is on your Docker Compose or your Docker project, and it will start with Docker. What it will do is take the compose file and build the image and then, of course, run it for you and run it with debugging capabilities. So when we go back to the Docker file here, you probably notice there's a couple of things here that probably don't follow the actual Docker file format typically because I wouldn't have some of that language here, but Visual Studio is hooking in and actually replacing some of these things, so we'll talk about that in a bit. Let's go to the compose file. One of the things to point out is the new tooling update will have this set to version 3, Docker Compose 3, of course. But right now it defaults to 2, and we have to keep it that way just for Visual Studio until I update with the new tools that are just coming, right? That doesn't mean that we have any issues with Docker Compose 3 and these Docker files, so you're going to see me be able to run this at the command line and actually put in play, use the latest version of Docker Compose. So this is defining my one service. Here's my Docker Compose file. And actually, if I just give this a run, this should run the application, load the browser, take me to the default page, and then I should be able to show hitting breakpoints, for example. So let's do that. And actually, while it's building, you can see there is a Docker output window, and it will show me things like, well, actually it's flipped over to debug because it's showing me my output, so let it finish. This is showing us all the build, and then I'm getting actually my logs there as well, so I'll come back to that as well. But see that it's running at port 32805, right? So I have an app, it's running. Let's go to PowerShell here, and let's do a Docker PS, or Docker images first. And you can see I have a demo 1 image here, right? 32 seconds ago. And then we have a Docker PS, and you can see that I'm running this image here, and that it's running at 32805, okay? So let's go back to the browser, and let me hit this and maybe pass in a value. And that ought to hit my breakpoint, which is the other method exposed by the controller, right? Here we are. So integrated debugging working, and you'll also see, if I come back to Visual Studio for a sec, that it actually shows in the logs. So you can see that it's capturing the logs right here in the Visual Studio environment. That's notable only because if you're used to working with Docker at the command line and you're used to tailing your logs so that you can troubleshoot that way because you're not using a debugger naturally, then you might come here and say, hey, let's go ahead and tail those logs. So I'm going to say Docker logs, and the image starts with, let me get back here, D9. And you don't see any output here, but that's because it's been hooked in Visual Studio. You're going to see that I can have control over this, though, if I come back to the command line and everything works naturally. So, okay. All right, let's go back here, and we'll stop debugging for the moment. So I just created a new project. I ran it with F5. I had breakpoints, and I was running a Linux container in another VM on my Windows machine. So that's already pretty cool. I think I'm done. I'm just going to go. No, just kidding. Okay, so what else can we do? So I have this experience that I'm showing you in the browser, in the Visual Studio environment. Let's go ahead and see what we can do with the command line. So I'm going to come here. And notice that we have this Docker Compose CI build. So what that is actually a compose file that uses the build image I mentioned earlier, and it will actually be used to produce the output for this solution. So what I'm going to do is show you how that works. So Docker Compose, and then let's use that file. So Docker Compose CI build YAML up. So what this is going to do is create the network. It's going to restore the packages for the solution, and then it's going to build the solution, and it's going to push it out to a folder structure that Visual Studio knows about for this solution. So when I was hitting F5, it was pushing things out to a Docker folder in the output, okay? And it's expecting certain things to happen in order for me to use that Docker file that I showed you had some special structure to it. It's also, when I'm in Visual Studio, mounting drives so that I have access to the NuGet packages and I'm not copying them over. So I'm not actually copying things into the image when I'm running in Visual Studio, whereas here, I'm actually building the output so that I can run a traditional compose app and do a build of the image and do the traditional command line stuff, right? So now this is finished. Let's do a clear and get out of here. And let's do a Docker Compose. And we'll use the usual compose up, and this will now build a new image and run it. And if I do a Docker PS, you'll see, let's do this up here. You'll see the image is running, and it's not got the dev tag anymore, right? So the dev tag actually came from an override compose file that was layered in Visual Studio. And now I'm just getting the default tag that was assigned to the image, and it's running at 32.806. So the question, so the question is, can I go over here and maybe modify this and go to 32.806? And it looks like that worked, but just to be doing a sanity check, let's do that. So it's all working. Now let's go back to the command line and let's see this. Docker logs, follow, and we'll go to, what's that container? E0, right? And so all the logs appear to be coming back now, right? So I'm out of Visual Studio, I'm doing a natural Docker build. So what's different about this from what I would normally do? Not much. I guess the only thing that I did differently was I used the CI build image, because that way I could leverage the same Docker file that was produced in Visual Studio and then also do a command line build that would run, you know, without me having to build my own Docker files and my own compose files that are out of band. So I can flip between the two ways. I like to, you know, force people to debug with their logs, because that way they have better logs when they go live. But that doesn't mean the debugging isn't useful. So we like that we can go between both environments easily and seamlessly, okay? So that's the idea. All right, so let's see what we can do with this in terms of Windows. And here I have my Docker file. So right now, my Docker file is a Linux-based image, and in order to build this for NanoServer, all I have to do is add -nanoserver, so that's the name of the base image for the same version of AspNetCore, and this will target Windows containers. Okay? So I'll save that, and then let's go to my compose. So a couple things about the compose file we looked at before. Number one, it relied on an override to set up development environment, for example. So I was working in debug and development environment. And also, we have this volume mapping I talked about, and the entry point was taken over for the log tailing and so on, okay? But what I want to do now is I want to run Windows containers, which right now in this current release doesn't debug, right? That's evolving. And so in order for me to run my Windows containers, I'm just going to go to my traditional command line, which I would have done in most environments anyway, okay? So what I'm going to do is I'm going to switch over to Windows containers. And while that's happening, I'm going to go ahead and create another compose file. So let me go ahead and copy, paste, and let's rename this to Windows. And the other thing I'm going to do, I'm just going to get rid of the extra files, because I don't need the override and the debug and all of those goodies. I just need a basic YAML file like I would normally do in a traditional environment. So I'm going to change this to version 3, because I want to show you that also, even though Visual Studio right now isn't templating to that, it still is perfectly working with Docker for Windows. And that will be about all we have to do. So my updated Docker file, my updated compose file here for Windows. Did I edit the right one? I might have edited a different one. Good thing I'm not going to run that again. There you go. Okay, so there we go. And let's go back to here. So what I'm going to do is Docker compose. And we'll do a Docker compose Windows YAML. But there's going to be one thing that's not going to work yet, and it's going to be the network driver. And so this is just a workaround also for now. There are the overlay network was just released, and so a lot of this stuff is not integrated yet. So the workaround for making sure that I can run this for Windows containers is I need to create the network. So I'm going to do this default and external and name NAT. That space before NAT, really important, just saying. Okay, right. And so now it will create the Windows image, and the Windows-based container will run, and it will work. That's what we hope for all demos, right? Okay, so let's see. Still working, still thinking. Let it go. And I'm just, yeah. Okay, let's take a look. Oh, it looks like it's running already. Okay, so I have, let me just get this to the top, Docker images, and we have a new image, and that is demo1. Let's go ahead and say Docker PS, and let's see where it's running. So I have this new container running. Now, how am I going to hit that would be the next question. Another sort of minor tweak, I guess, to get to it. So localhost is not mapped right now to the Windows container, so I need to find the IP address of it. So what I'm going to do is do a docker exec. And EC is the name of the container, I think. No, it's 9E. And we'll do an IP config. And we'll grab that little guy because we need it. And we'll go back to the browser. And let's get rid of this guy, paste that guy, and boom. Now that seemed to work, but just in case, hello, and it seems to work again. So I've now taken the same code that was generated with the CI build, and I've switched over to Windows Compose file, version 3, and a Windows Docker file. So basically, I've updated the base image is all. And I had to add a workaround for the networking for now, and up and running we are, right? So all good. Okay, let's see what we got next. Okay, so we're going to take a switch to existing applications, right? I already have AspNetCore applications. I've got a web app and an API. I want to Docker enable those, and I've already got the solution. So I can also add Docker support. There's menu commands for that. And what it will do is similar to what we've already seen, but I'll show you. It will create the Docker file, create the Docker project, compose files like we expect, right? And ready for debugging. I'll go through the process with, again, a web app and an API, so multi-container deployment. And then we'll talk a little bit about environment variable overrides as well, okay? So with that, let's go back. And here we go. I have a web app. So this runs without any Docker settings right now. So there's no Docker file, there's no compose, etc. So I'm going to right-click on this web app, and I'm going to add Docker support to that. And when I add Docker support, it adds the Docker file, it creates the compose project, and gives me an out-of-the-box compose file for, again, it's going to be a Linux-based container as well. And let's see. So here it is, Docker file. It's based on AspNetCore 1.0 only because the app is based on that. So it's intelligent enough to figure out what base image I should have, okay? And our Docker compose is here. And same as before, we've talked about that. So now I'm going to add the web API. The order in which we add doesn't actually matter long-term because you'll be able to manipulate the Docker compose project to say which is the starting app. But if I start with web app, then by default, it will do the right things here and also in the compose file. So you'll notice that this just added then web API. So I now have the multi-container compose file ready to go, and I have another Docker file here. Okay, so I should be able to just run that, and the web app will run, and it's a Linux container, so it will, do what I showed before, only possibly more interesting, or there could be errors, and sometimes that happens. So let's see. Okay, where's my pair? How many people are here? And I said to you, am I going to forget to switch to Linux? I didn't do that on purpose, just so you would know it happens. Or maybe I did. You're never going to know. Okay, so let's see. If I had $1 for every time that happens, actually, I don't know. Okay. I suppose we don't really switch between them all that often in the real world. So, okay, so this is going to load up. Right now, what it's doing is just building both images, actually. So the output window will show us that progress. We've got debug lighting up. And at some point here, we ought to start seeing the web app. There we go. So I have a prettier web app. It's a medical conference site with a lot of loriciptum in it. Very interesting. I hit speakers, and it should be trying to hit the API. But I need the content from the API to show this page, and it's not working because I haven't set up the DNS for it, because the app was set up to go against my configuration for development with localhost some port, and what I need is for it to actually just respect whatever the network name is, right, for that API, which is web API. So let's go back to the application. Back to Visual Studio, stop this, And let's see what we can do. So going to my web app, we have an app settings section. Here is the culprit, right? Not going to work. I'm not going to edit it here though. Let's talk about environment overrides. So the nice thing about core, of course, is a lot of things, but one of them, one of my favorites, is that there's a lot of nice plumbing for configuration and overrides. I don't have to build this. I used to write custom code for this all the time, right? For looking in the database and then looking in the overrides in the a text file or wherever. So we have environment variable overrides that are natural to Docker. We want that to be respected, and this is all going to just work. So all we need to do is provide that environment variable. So let's go up to the compose, and what I can do is modify this guy and put environment, and let's call it API base address. Might be important to spell it correctly, just thinking, and web API. Web API refers to this guy by its name, okay? So I will now be able to run this again, and just to give you some clarity, Docker network. There is actually a network that was created here for this guy. And if I wanted to inspect it, Docker network, inspect, and that would be E8. Oops, sorry, I forgot something there. Yep. Double C. See, now you pair with me, right? You forget the whole Windows thing, but whatever. Okay. So now you can see, oh, is that the right one? Not the right one. Not the right one, Michelle. Docker. That sounded like a horror movie. Oops. Okay, so probably, if it wasn't E8, it's 35, right? Yeah. Okay, so Docker network inspect 35. There we go. Web API, web app. So now I should be able to hit that. And it should show everything we were expecting, and it looks like it did. So I got my speakers, and I can go over here, and I got my set of sessions. Looks like a very interesting conference. Let's move on. Now, everything I just showed you, again, multi-container, add Docker support. It defaulted to Linux container in my Docker file. I'm using, of course, the version of Compose that's coming with Visual Studio. But if I flip over the command line, update that to version 3, I can do exactly what I did before, but multi-container. If I change it to a Windows base image and add nano server, then also that will just work. So I'm not going to go through that again, but it's the same idea. Okay, so there's no more magic beyond the little networking side step, which will eventually go away. Okay, so let's get back to business. Okay. So, migrating apps, let's move to that. So, our legacy applications could be many different platforms. We've already talked about that and the idea that you need to be able to encapsulate all your dependencies and so on, but there's a couple of other things that could be interesting to talk about besides the dependencies in the container. So what I'm going to do is take a real app that I have. I went and found a version of that thing that it's so dusty and old, I'm surprised it even ran. And I took it from an old tag. It's called Snapboard, one of my product things that I've built years and years ago. And I really did a migration, and it actually worked. What do you know? So Microsoft ASP.NET would be the base image for that, and that will be a full Windows Server core with IIS, and then rigged up for whatever else I need, and deploying my app to root. And then we're also going to talk about a little bit of Compose Up Developer Love, which really is just, can I light up the whole environment for my devs so that they can develop locally, have their database, have their Kafka, have whatever it is they need. In this case, it'll be the SQL Server version of that, okay? So let's take a look. And here is Snapboard. So this is a 4.5 app. So I guess it could be more legacy. Okay, understood. But still, there's code smell. So I open up this app. It has already the Docker support, but I did the same thing as we talked about before. Right click, add Docker support. It produced this Docker file. Now, I added a couple things, again, for some of that networking workaround, because some caching that goes on once I added the SQL Server container. So I would say I'm putting a reference in the slides so you can take a look at that, but this will go away once the overlay is working and some of the other networking things for Windows specifically. So this is now Windows containers focus when the issue that I'm talking about related to networking. So continuing, same old overrides Visual Studio provides so that I can have a debugging experience, which I expect also for my legacy apps, right? Especially those, because they're not rigged up for logging. Nobody thought about that. And then, of course, this entry point is a special edition to handle some config workarounds, which I will get to. So Dockerfile otherwise, pretty normal. Base image, the one I talked about. Let's come back to the Docker Compose. So again, I get a Docker Compose. It has my Snapboard application. And for Windows, it's actually defaulting to 2.1. Again, this is a tooling thing. So 3.3 will work at the command line. I'm using 2.1 because I'm running in the debugger, okay? And that's that's the tooling that comes with this environment. I'm going to remember to do this now because I get a star. And we're going to go over to Windows containers before I run this little guy. Couple other things to talk about though. So what's special about this app? Well, it has a lot of configuration settings, and I do need to update those configuration settings when I move between environments. So I have to have a way to override those, but I don't get the fancy, AspNetCore environment overrides that I have out of the box in the new, modern application. So I just had to write a little bit of code that would look to see if we had an environment variable and use that instead, right? And that's not an uncommon thing to have to do, so maybe part of your migration considerations. Here is that code. And aptly, we're also hitting a breakpoint, check, achievement unlocked. There you go. So we have this, legacy application with a breakpoint. Isn't that awesome? I know, you just can't even contain yourself. So I'm going to continue. And this will run the actual application. Now, the other thing that happened while we were talking there, or we weren't talking, I was, is it built and ran also the SQL Server image, but I'll come back and show you that. I made a little snapboard for this called DockerCon, just to show that real images are coming up and that it actually had the environment override working and found the graphics that I put in the correct storage account. I'll go back and show you why that worked, because there's actually a mistake in the original web config and the override is correct, okay? So basically this is just apparently a slowly loading page. There you go. And it just kind of illustrates that something's working. Plus it looks nice, doesn't it? DockerCon 2017, who knew? So this is running, it's a legacy app. I migrated it, and it's using the AspNetCore base image. If I come over to look at some of the other things I had to do to fix, let's take a look. So one thing is I am using in my Compose a SQL image, so the developer image. So those are both being spun up. And of course, it is local only, not going to production. There is no passwords being shared, nothing like that. Never, ever, ever put passwords in your Compose or elsewhere that go into secrets, Docker secrets and a vault. That's how it works. Okay, you already know that because there's been talks about that already. So just making the point to be responsible. And I also added a couple things. I put a depends on MS SQL here to show that we can also still use health checks, for example, in Windows containers. So legacy application, and now I've got a health check to make sure MS SQL is up and running for my local container dependency. And that's working here. The other thing is, here's my environment override. Nothing too suspicious here, but if I showed you that the original setting that has the images and so forth is actually misspelt, accounts, then obviously that wouldn't work, but because of the override working, everything's good. But you're thinking, environment variables work. I've already done this before. And the answer is yes, that is true. But our, environment actually, when you run the container, it is the starting process that gets the environment variables, which is IIS, and we need it to go to our application, which is running in an application pool. And so a workaround for that is to just have this couple lines of code in a bootstrap written by Elton, who actually introduced me. Woohoo for Elton! And so we actually, my team found that before even this, because we were migrating some other stuff. Anyway, and the service monitor is then started there. So what that means is I'm slightly changing my Docker file to say the entry point is this PowerShell script that does that work instead of the default entry point, which would have been to start service monitor, workaround achieved, and it's a minor thing until there is another solution for the same problem. But it's not really a big deal. Of course, this presumes that your container is isolated from other assets and that it's okay that the whole machine has those environment variables, and of course that they don't contain secrets anyways because you wouldn't do that in the first place, right? So that's the idea. Okay? Good. All right. Let's return here. And I've got some references here just to, at least when you see the slides, you have a reference back to the DNS resolution things for me to be able to run SQL Server and Compose until the networking resolutions are there. Environment variables and IIS, a couple of references. And let's talk about, of course, now we've talked about dev. I've built a core app, run it in Linux containers, shown debugging, shown logs, shown how to switch over to Windows with the same actual code, build a new image, run it in Windows, switch between environments, Linux and Windows. We've done a lot. It's only been like half an hour, right? Or so. And multi-container DNS, and we've talked about, migrating legacy apps. I mean, there's nothing left for you to learn, really. But what we can do is talk about how we finish off, right? I'm a developer, I'm working on my own machine, I want to check in, and I want stuff to happen, right? If I'm using, Visual Studio, I'm not necessarily using Visual Studio, VSTS, for example, if I'm a .NET developer, but let's just assume we are just for the sake of tying together that Windows and developer story for .NET. If I'm using VSTS, I might have a Git or TFS-backed repo, and my service goes there. So I'm going to check in some code. Maybe 3 people will. I don't know. There's 3 people up there. And what I want is to get a build definition working so that I can pull latest and have that build my images and have that push my images to my registry of choice, which could be Azure Container Registry if I'm building things for Azure. It could also be the Docker Enterprise Edition registry if I'm doing things with that platform. So the idea is whatever registry of my choice, I can automate this whole process, check in and have it work. And then ideally what I want is to control the tagging. That's the most important part. Building the image, pushing the image, all good. The tagging is the thing you think about so you can get it out to environments in a very smooth and structured way. So we'll talk about that in a second. But just to show you, I can create this type of build definition, and I can control the tags, so that's all good. This is from Visual Studio Team Services, right, VSTS. The build output will show as it's building when I check in and it starts to do its process. And I'll be able to see the steps as it progresses and how much time each step took. And then I also can see the end result in my Azure Container Registry. In fact, if we even have a few moments to show that, I can go here. And let's take a look at this ping pong example, because it's a simple one. And I can say ping pong Docker. Not that that has any particular meaning, but I can do a check-in. Let's do it. Commit. And I'll go down here. And let's grab this guy. Oops. Okay. Got to find the one I care about. Let's just kind of close a couple things. Here we go. Right click and stage. All right. So we'll do this and we'll say updated. Boom. How about that? There. And we'll commit that. And then we'll do a sync. And this should take care of that. So am I pushed? Let me see. Push. Okay. Push, boom. That means something. Let's head over here and see what we get. Build definitions. Anything queuing? Anything? Bueller? Maybe I can refresh. Ah, there it is, 268. Yeah, okay. I have a build in progress. That's awesome. I can go take a look. It'll show me all that lovely output. And I've got the CI part taken care of. Eventually, I hope that will appear over here in my repositories. So I can go over here and see ping pong core, and I should get a new version. All right, good. So the last step would be the CD part, right? So there's work going on to improve that story, right? That's still early days, I think, with the VSTS story. But of course, there's other tools that we can use to achieve that. And the other thing to consider is that the correct tag, that whole process of tag and pull can be also not only initiated by another tool like a run deck or by VSTS when all those features are in place, but also the container platform itself, right? The orchestration platform, you need to give it the keys to the registry, give them read writes, and give it, any sort of tags that you like to pull. So you could ideally have some other process that's updating the container platform, instructing it, go get a new image, or sometimes force pull images when things need to restart, for example. And so this is another way to handle that. At any rate, the story gets more and more complete all the time, but these are all good tools. I think the summary that I would give you then for this talk in general is you're a .NET developer, the investment should pay off because we do have Windows containers. We can migrate full-blown legacy apps. That could be useful when you're starting to tease things apart into a microservices architecture and strategy, allow you to bring the old with the new, and get that all into one container platform that you can manage, because that's obviously, your DevOps investment, and you don't want to have scatters of many, many things to manage, I think. And ultimately, what you want is for everything to work on your machine and hopefully everywhere else as well. So with that, I say thank you, and I hope you enjoyed that, and let me know if you have any questions. Thanks.